Okay, I'm trying to find the box inscribed in the sphere of radius 2, centered at the origin, with the maximum volume. So, first off, I'm going to say the box with all corners on this solution set, and in particular the box with the 8 corners at plus or minus x, plus or minus y, and plus or minus the square root of 4 minus x squared minus y squared. That is 8 different points because you've got 2 options for the first slot, 2 options for the second, and 2 options for the third. That's 2 times 2 times 2 is 8 options. So you could probably picture this box very easily. The idea is for every pair of numbers, x and y, say every pair of positive numbers, x and y, in the floor of the three-dimensional space that we usually draw, there is a unique box inside the sphere who's got one corner just above xy on that sphere, and then the other 7 points are obtained by just attaching pluses and minuses to the various components. Okay. Okay, so the idea is the volume of that box is the width of that box is 2 times the coordinate x, right? The distance between the coordinate x and the coordinate negative x. And the width is 2 times y, and the height is 2 times the square root expression. So all in all, we have 8 xy square root of that stuff. Now, the function that we're looking at right here, if we were to try to find the critical points of that, I just wouldn't look forward to it, because the derivatives are going to use both the product rule, because we've got the product of xy and the square root, and also the chain rule. We'll have to take the derivative of square root, giving us a 1 over 2 times square root times the derivative of the inside. Sounds like a lot of work. So instead, I'm thinking I'm going to use a common trick. Instead of finding the maximum values of that function, I'll find the maximum value of the square of that function. So here I am looking at v squared, and I've also put a 1/8 in to get rid of that 8 so I don't have to carry it around at all. And certainly you would agree with me that if a function achieves its maximum value at some coordinate, then the square of that function also achieves the maximum value, its maximum value at the same point. And similarly, if a function achieves its maximum value at some point, then some constant times that function achieves its maximum value at the same point. So I'm incorporating both of those things to make my algebra a little bit easier. And so dividing by 8, getting rid of that, and squaring every term here gives me an x squared, a y squared, and then multiply all that by 4 minus x squared, y squared. That would give me an x times y times 4, x squared times y squared times 4. And right here, an x squared times y squared times x squared would be an x to the 4th y squared. And then an x squared y squared gives me that term. Now if that gradient of that is going to be 0, 0, that gives me 2 equations. The derivative with respect to x equation and the derivative with respect to y equation. And you see that I've got an 8 here and from pulling down that 2, if you will, from the power rule, and the 4 there from the power rule again, and the 2 there from the power rule again, and then similarly down here. Now I notice that this equation and this equation are the same in the sense that if you take this equation and swap all of the x's for y's and all the y's for x's, then you'd get this equation. That's kind of helping me think about things as I go along. Now, first thing I saw here is that every term in this expression has both a factor of x and a factor of y, so I wanted to pull all of those guys out. They also all have a factor of 2, so I factored out 2xy, leaving me with this. Okay, and as per the usual thing, if you have the product of 3 things, x, y, and that expression, then one of the 3 of them is equal to 0. So either x is equal to 0, or y is equal to 0, or, and let's see, if not x equal to 0, not y equal to 0, then I might as well take this expression that has a y everywhere in it, and divide out by that y to give me 4 minus 2x squared minus y squared. And then similarly down here, one of the three factors is 0, and I can cancel the remaining x. You know, I could have factored out an xy squared up here, and I could have factored out an x squared y down here, but I did things a little bit differently. Now, I am not interested in solutions to this system of equations where x is 0 or y is 0, so I say the solutions with x not equal to 0 and y not equal to 0 are solutions to this system of equations where you just have those two. And I'm going to rearrange this to have y squared by itself. Y squared then is 4 minus 2x squared. And then I'll rearrange this to have x squared by itself. X squared is 4 minus 2, and then instead of y squared, I will substitute in this expression 4y squared. See how I did that? I substituted part of this equation into that equation. That is to say, I substituted an expression for y squared in 4y squared. Okay, so I need to continue from there. Let me see, what can I get? I've got a 4 minus 2 times 4. That is going to be a negative 4 overall. Negative 4. And let me think about how many x's I'll have. Negative 2 times negative 2x's. That'll overall be a 4 with an x squared. And then I'll have to subtract 4 from that. Or I could just factor out the 4 like this. And that will be equal to x squared. I think let's see, I just simplified the right side of that equation, and I need to include the left side too. Here, maybe I can, minus 4, and I am going to write equal to 0, and then I'm going to change my 4 to a 3 here. Right, because I had x squared is equal to 4x squared. So I'll just rearrange and get 3x squared and 0 on the other side. I think I did everything right there. And what does that say? If I simply recopy this equation, y squared is 4 minus 2x squared. This is amounting to the statement that x is 2 or x is negative 2. And I could use that up here. Let's see, y is plus or minus the square root of 4 minus 2x squared. Well, the solutions to this, I am a little bit worried that I might have made a mistake somewhere. Because looking at this, oh, you know what I did? It was this. I got confused by my parentheses. They shouldn't have been there, right? The parentheses should not be there. Let's see. How do I do that? Okay. So I've got x is, let's see, 2 over square root of 3. It looks like, great. So move the 4 over there and then divide by 3. That'd be 4/3. Square root of that is 2 over square root of 3. So 2 looks like I can remedy this pretty easily over the square root of 3. And then here, 2 over square root of 3. See what I was afraid of? I was going to take 4 and subtract from it 2 times 2 squared, and that wouldn't be good. Now I'll take, okay, so which has solution set. Solution set to that. Let's see, if I have 2 over square root of 3 for my x, then y is the square root of 4 minus 2 times 4 over 3. 2 times 4 over 3 is 8 over 3. 8 over 3. And let's see, 4 is 12/3. 12 minus 8. 12 minus 8/3. That's what I'm going to be looking at. And won't that be 4/3? Square root of 4/3. Okay, so square root of 4/3 is 2 over square root of 3. All right, but I forgot my plus or minus. So also 2 over square root of 3 negative 2 over square root of 3. But that was just the solutions that corresponded to x being positive. Then there's the negative solutions. You know what? This is feeling rather redundant, isn't it? I mean, if I only want well, right. So these are all the same boxes. Oh well. I'm going to have to write out the solution set anyway. There's the version that looks like this, and the version where everybody is negative. Okay, so there are 4 solutions, but all 4 of those solutions actually encode the same box. That is to say, there is only one extreme value, or only one critical point. And if we're to believe that this box has, well, if it has a maximum volume, which seems perfectly reasonable. I mean, I could use the second derivative test here for sure, but I think I'm ready. I'm just prepared to say that the box of largest volume has dimensions well, it's 2 over square root of 3, 2 over square root of 3, and then let's see, we need to figure out now what that z is. So let's see. Square root of 4 minus 4 thirds. Okay, so let's see. This is 12 thirds minus 4 thirds minus 4 thirds, and that's 12 thirds minus 8 thirds again, and then you take the square root, and that is right. So the square root of 4 thirds again, which is 2 over the square root of 3. So IE is a cube. Oh, that makes sense. The box of largest volume that you could construct with all of its corners on a sphere is a cube. I think that makes a lot of sense. I believe it.